everybody, this is the Algebra 2 video on section 2.2.4 for Monday, November 6th. Since I'm going to be out, I want to make sure that you guys have everything you need to be successful today. Second hour, I'll be out all day. Third hour, I'll probably be back towards the end. So in this section, we did talk a little bit about circles on Wednesday. And there's going to be some points within the video where I'm going to ask you to just pause it and then do some math, because I might do it a little faster than what you might feel comfortable with, okay? Also, whenever I'm doing this, if I have the need for graph paper or other paper, please make sure that you are also reaching for graph paper and other paper. I know the first one, I do have some graphs here, so that should be helpful. Okay, so today we're going to be graphing non-functions. We talked about the most popular non-function as being that of the circle. So in this lesson, our learning target is to be able to transform non-functions. In this lesson, you're going to consider two new parent graphs that are different from ones that you have seen in the past because they're not functions, although the circle you have seen. You'll investigate them and apply the knowledge you have gained in this chapter to transform them. You will identify ways in which these new equations are different from the functions in which you have been working with. Okay. So in the first question, question 132, and we won't be doing all of them, we're just doing the ones that we've decided as a team that we're going to do. We're not going to use a calculator. So begin by fully investigating x equals y squared and x squared plus y squared equals 25. Now, given what we did last week, some of you may know what that is, but we're going to end up using a table for that, okay? So without using a graphics calculator, make a table and a graph for each equation. So the first one I'm going to do is x equals y squared. So the question always becomes like, what is it easier to use? Is it easier to put numbers in for x and figure out the y? So like would I put like 5 in for x and figure out what y I square to get that? Or is it easier to put a number in for y? In this instance, I think it's easier to square a y and find the x. So I think to myself, okay, what kinds of numbers can I square? I can square positive and negative numbers. So my inputs this time, which are actually your range, which is crazy because we usually do everything in the x's, we're going to go -3, -2, -1, 0, 1, 2, 3, and I can go with 4. When I made the tables, I only went so far. I might have to go longer in other tables. But this makes sense, you guys, because it's easier to square y's to find the x's. So -3 squared gives me 9. So my x would be 9. That makes sense because 9 is equal to -3 squared. If I square -2, wouldn't that be 4? If I square -1, that's 1. 0 squared is 0. Putting 1 in there for y, 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. I think we've done something before where we didn't quite get everywhere. So then I'm going to graph this. So I'm going to have a point at 9, -3. I'm going to have a point at 4, -2. I'm going to have a point at 1, -1, 0, 0, 1, 1, 4, 2, 9, 3. I can't get the last one on because I can't go up to 16. So here we go, you guys. I'm going to connect these. Okay, this is it's a parabola. But it's a parabola on its side. And it makes sense from what we talked about last week for it not being a function because this input of like 4 has 2 outputs, right? So that input of 4 right here and here has 2 different outputs. So that's why it's not a function. So that's something new. It's a parabola on its side. They call those sleeping parabolas. All right, the next one I have here is I have x squared plus y squared equals 25. Now, for this one, it's like, okay, is it easier to find the x squared or is it easier to find the y squared or what are we going to do here? And so this is going to be kind of interesting for me because I'm not really sure how we're going to go about doing this. But we are going to start with, first off, some of you may know what this is, and I totally do. But if I would go in and start picking some numbers, okay? So let's just say, I'm going to use a different sheet of paper because I don't think this is going to work. But let's say that my x value, let's say I made an x value of 9, you guys, okay? So let's just say I put 9 in for x, and I would have 9 squared plus y squared equals 25. Well, 9 squared is 81, right? And if I subtract 81, can I square a number and get, I don't even know, I don't even care what 25 minus 81 is because 25 minus 81 is a negative number. 25 minus 81 is -56. Can I square any number and get -56? No, I can't. So here's the deal. I can't pick just any darn number for x because like 9 was way too big. So the question becomes, what can I use? When I did the math, you guys, did you see that at one point I took that 81 and I subtracted 81 from 25? So the question becomes, what can I subtract from 25 that would still give me a y squared? Well, can I subtract 25? I could. What x do I square to get 25? Well, it looks like I'm gonna have a 5. So I'm gonna pick an x of 5 because that works, okay? And I'll show you why 6 doesn't work. But I'm gonna use this as scratch paper just because I know my resource page is gonna run out of space, okay? And I think you guys can still see that. All right, so let's put a 5 in for the x. We're gonna have 5 squared plus y squared equals 25. 5 squared is 25, that's plus y squared, and that equals 25. Subtract 25, y squared equals 0. So the square root of this would be y equals 0. So there is a point at 5, 0, okay? Now, to further kind of look at things and why 6 would not work for an input, again, we're doing x squared plus y squared equals 25. All right, let's just try an input of 6 and show you that it doesn't work. If I take 6 squared plus y squared, and that equals 25, sorry, this would be 36 plus y squared equals 25. We are not having great luck with this pencil. Subtract 36. All right, I'm getting, what, like -9 equals y squared? Again, I cannot take any number squared and get -9. So therefore, it should make sense that I am only gonna choose numbers here, you guys, that give me, like in this spot, a 25, because I can take 25 minus 25, okay? So the next one I'm gonna do is 4. I'm gonna put 4 in for my x, okay? So again, it's x squared plus y squared equals 25. I'm gonna make sure you can still see this, but let's put 4 in there. I'm gonna try to make this a little better. So again, let's do x equals 4. Okay, here we go. So we're gonna take 4 squared plus y squared equals 25. Well, 4 squared is 16 plus y squared, and that equals 25. Subtract 16. Y squared equals, that's 9. Take the square root of that. Oh, wouldn't y equal, what's the square root of 9, you guys? It's 3, or it's -3, right? Because 3 times 3 is 9, or -3 times -3 is also 9. So y would equal plus or minus 3. That means for an input of 4, I can get outputs of 3 or -3, okay? So let's see what we got here on this resource page. So I put 4 in there. My y could be 3 or -3. So far I have a point at 5, 0. And at 4, I can be at 3 or -3, okay? Makes sense that I'm gonna have this non-function, I think. Next, let's throw 3 in there. See what happens with 3. X equals 3. So we're gonna have 3 squared plus y squared equals 25. 3 squared is 9 plus y squared, that's gonna equal 25. Subtract 9. Y squared equals, what is that, 16? Take the square root. Same thing, y equals, what's the square root of 16? It's positive or -4, because 4 times 4 is 16, and -4 times -4 is also 16. So that means when my input is 3, my output is 4 or -4. All right, feel pretty good about that. All right, the next one I'm gonna do, oh, sorry, I should graph that too. At 3, I should be at 4 or -4. I feel good about that. All right, so here's the deal. With 2, here's the thing. Let's try x equals 2. You guys know that I really like nice answers. So we're gonna take 2 squared plus y squared, that should equal 25. 2 squared is 4, 4 plus y squared equals 25. Subtract 4, y squared equals, that'd be 21. If I take the square root of 21, you guys, it does exist. It's like 4 and change, but I don't wanna use that because it's not nice. So I'm not gonna use an input of 2. 2 doesn't seem to be a great one. Let's try 1. So I would have 1 squared plus y squared equals 25, equals 25, my bad. 1 plus y squared equals 25. Subtract 1, y squared equals 24. If I take the square root of both sides, you guys, yeah, I can take the square root of 24, but it's nasty. Again, it's just short of 5, but I want to use that, okay? So let's see if I can use an x of 0, see what happens with an x of 0. So again, we're going to have 0 squared plus y squared equals 25. Well, 0 squared is 0. Y squared is going to equal 25. Take the square root. The square root of 25, you guys, again, it's positive or -5. because 5 times 5 is 25, and negative 5 times negative 5 is also 25. So an input of 0 gives me outputs of 5 or negative 5. There's a 5 and there's a negative 5. All right. Ooh, it looks like I have a semicircle so far. Kind of cool. All right. I filled up that sheet of paper. You should be doing all that on scratch paper, okay? Next thing, let's look at my next input. Okay, if I put negative 1 in there, let's think about this, you guys. I want to just use nice numbers. So if x would be negative 1, again, we're using x squared plus y squared equals 25. Negative 1 squared plus y squared equals 25. We already kind of did this because isn't 1 plus y squared equal to 25? We kind of did that. Subtract 1, y squared equals 24. Take the square root. The square root of 24 exists. There's 2 answers. But hey, I don't want to use nasty numbers, so I'm not going to. So we're only going to use nice ones, kind of like what we did with square root functions. Let's try x equals negative 2. If I take negative 2 and I square it plus y squared, and that equals 25. Negative 2 squared is 4. That's plus y squared, and that equals 25. We did this kind of before, right? We said y squared equals, that's 21. Again, you can take the square root. It does exist. There is a point where x is negative 2, but it's not pretty, so we're not going to use it. The next one, let's use x of negative 3. So I'm going to take negative 3. We're going to square it, plus y squared, and that equals 25. Negative 3 squared is 9, plus y squared equals 25. Subtract 9. Y squared equals 25 minus 9 is 16. We're going to take the square root. That is nice because y would equal 4 or negative 4. Because again, 4 times 4 is 16. And negative 4 times negative 4 is also 16. So an input of negative 3 gives me outputs of 4 or negative 4. So at negative 3, we're going to be at 4, 1, 2, 3, 4, or negative 4, 1, 2, 3, 4. All right, let's try negative 4 and see if that works. So an input of x equals negative 4. Again, we're going to take negative 4, we're going to square it, plus y squared, and that equals 25. Negative 4 squared is 16, plus y squared equals 25. We're going to subtract 16 from both sides. Y squared equals 9. Yep, square root of 9, that exists. Y is going to equal 3 or negative 3. Again, because 3 times 3 equals 9, and negative 3 times negative 3 also equals 9. So an input of negative 4 gives me outputs of 3 or negative 3. Negative 4, 3, or negative 3. I do 1, 2, 3. Sorry about that. All right, let's go with negative 5. Let's see if that works. X equals negative 5. So we're going to take negative 5, we're going to square it, plus y squared, and that's going to equal 25. Negative 5 squared is 25, plus y squared equals 25. We're going to subtract 25. Y squared equals 0. Take the square root. The square root of 0 is 0. So when our x is negative 5, our y is 0. So I'll put that right there. There's only one answer there, which is kind of nice. Okay, next. Let's try x of negative 6. So I'm going to take negative 6. We're going to square that. Plus y squared, and that should equal 25. Negative 6 squared is 36. Plus y squared equals 25. Subtract 36. Y squared equals, what's that, like negative 11, I believe? Yeah, no, negative 9. I'm sorry. Can you take the square root of a negative 9? No, you can't. So it looks like our x's, our inputs, you guys, can only go from 5 to negative 5. And we did have answers, like we talked about how we'd have like little decimals at, like it was going to be 4 and change at 1 and 2. So here we go. We're going to make a circle. And then we're going to make sure we answered the question. So welcome to my non-function, which makes sense because inputs gave me more than one outputs. So it says, without a graphics calculator, which I did, make a table and a graph for each equation. I totally just did that. All right, I'm going to set this aside and see if I have to, and you guys have this in front of you, for the next one if I need it. Okay, Maribel and Lisa were working on this problem. Maribel was making a table for x equals y squared. X equals y squared, you guys, was the very first one. It was this parabola. They call this a sleeping parabola because it's like on its side. Yeah, so original, right? All right. So they were making a table for x equals y squared. For the y, or the x value of 4, she found the y value to be 2. Lisa was watching and said, wait, an x of 4, there is another possible number for y. What did she mean? Okay, so for an x of 4, x value of 4, okay, so let's see here. Oh, sorry. I put some negatives here, my bad. So for an x value of 4, I should have 1 at 2 and -2. My bad. I don't know why I put this at negative. Hopefully somebody out there caught that. All right, and I think we did a couple things. So let's kind of look back at this, you guys. I've had my inputs. These are all of my inputs right here, and then I had my outputs. Yep, and let's see here. This is also going to be positive. I don't know why I put that as negative. My bad. So if my input is -3, because we put these numbers in for the y and we found the x, -3 squared is 9, which I have that. 9, -3. And then if it's -2, -2 squared is 4. -1 squared for y, -1 squared is 1. 0 squared is 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. So I did okay. I don't know why I put those as negatives, and I do sincerely apologize. All right, so we should have a point at 9, -3. So the question they had was, going back to this, when x is 4, there's another possible answer for y. Yeah, there is. Because when your x is 4, so if I have a 4, it's basically saying, what do you square to get 4? So, and we already have that. So we'd have x equals y squared. They say when x is 4, there should be 2 answers, because we said it was 2, because it's 2 squared. So we'd have a point at 4, 2. But if you think about it, 4 also equals something else squared, and that would be -2. -2 squared is 4. So we would have an x of 4 would also give me a y of -2, and therefore we had 2 points at 4, 2, and 4, -2. Again, I apologize for the beginning part of that. All right, now describe x equals y squared and x squared plus y squared equals 25 completely. This includes finding the domain, the range of each equation, finding the important points such as the intercept, and describing what happens to y as x increases. All right, so I'd like you guys to pause this, and I want you to do that. I'm not gonna have them written down. I'm gonna actually write those things down after I'm done with this video, and you can check the answers in the front of the board, okay? And then D, how are these relationships different than what you were working on? So as you're working on part C, you guys, and I will have descriptions for, I'm gonna have 2 of them. I'll have one for x equals y squared, that'll be on this side, and I'll have one for x squared plus y squared equals 25 on this side. I'll cram all that stuff in there. I'd like you to check it and then also look at that with your peers. All right, then we're jumping over to question 135. Write your general equations for the circle in standard form by rewriting the equation in that form to isolate 25 on the other side. What information does the locator point, HK, give about the graph of the circle? Okay, so they want me to change it to 25 equals, okay? So here's what I got. This is kind of complicated because there's all these variables, and this kind of sucks. Y equals plus or minus. We're gonna have the square root of, we have the opposite of x minus h squared plus 25, and that's plus k. All right, so that is the general form of a circle. It doesn't look great, but hey, it's going to in just a bit. So the first thing I'm gonna do is I'm gonna subtract k from both sides, okay? So I'm gonna have y minus k, I probably don't need parentheses yet, sorry. That's gonna equal plus or minus the square root of the opposite of x minus h squared plus 25. All right, guys, the next thing we're gonna do is get rid of this square root, and we are gonna square both sides. When I square both sides, it doesn't matter if this is positive or negative, because if I square anything, what's the answer? It's always positive. So we're gonna have the opposite of x minus h squared plus 25. That's gonna equal y minus k squared, okay? All right, next thing I'm gonna do is, hey, this is gonna seem weird, but I can get this 25 by itself, you guys, by adding the quantity x minus h squared to both sides. And that would be x minus h squared plus y minus k squared equals r squared. Or I'm sorry, equals 25, my bad. All right, and so that would be it. Now, h and k for this one, you guys, what information does the locator point HK give you? That is your center, okay? We actually talked about this when we had x squared plus y squared equals r squared. That was what we talked about on Wednesday, on Wednesday. That's the radius squared. Would it make sense that h and k here would be 0? So this tells you that the center of the circle is at 0, 0, and the radius is, it equal to the radius squared, that'd be 5. Guys, that's the exact equation that I just had here, okay? So there you go. So I wrote that general form. What information does the locator point HK gives us the center of the circle. All right, there it is. All right, next. So a circle has a special characteristic, its radius, which defines its size. Okay, refer back to x squared plus y squared equals 25. What is the radius? Okay, so that was this guy right here. Guys, it's easy to count the radius. It's 5. From the middle, we go 5, 5, 5, 5 up, 5 down, 5 right, 5 left. R equals 5. How is the radius related to the equation? Well, 25 is equal to, it should be equal to r squared, okay? So it's always equal to the radius squared. What would the equation of a circle that has its center at 5, -7 with a radius of 10? How about the 12? Okay, let's start with the first one. So we talked a little bit about it's x minus h squared, right? There we go. So hk, you guys, we said gives us the radius. It's like having the horizontal shift. It's always the opposite. So for this guy, the first one, what would the equation be? The quantity x minus 5 squared, because it's 5, plus the quantity y. Okay, if it's minus a -7, isn't minus a -7 plus? That's going to equal the radius squared. The radius is 10. That would be 100. So that's that guy. How about if the radius was 12? Okay, same center. So it's x minus my x coordinate, which is 5. We're going to square that. Plus y minus my y coordinate. Minus a negative is plus 7, and we're going to square that. And that equals our radius squared. 12 squared is 144. Now generalize the connection between the radius and the equation of a circle. Write a general equation for the center hk and radius r. So here we go. We kind of just did that before, right? Didn't we just do this right here? The only thing is we're not going to have 25. 25 was the radius squared. So center is hk. We're going to have x minus h squared plus y minus k squared equals my radius squared. That's your general form. All right. Given the equation, the quantity x minus 3 squared plus y plus 7 squared, that equals 169. Find the radius of the circle. How can you? Okay, I'm going to give you guys, press pause, try to figure out what is the radius, and then I'll come back. All right, if you notice, that always equals the radius squared. What do you square to get 169? 13. So the radius is 13, and I'll even put units because it should be 13 units. All right, 137. We are almost done with this video because I think we go up to 138 or maybe 139. I'm just kind of looking at this. So consider this equation right here. What's the shape of the graph? How can you tell? Well, I'm looking at this and they're both squared. This is a circle because it's in the form x minus h squared plus y minus k squared equals the radius squared. What information can you learn about the graph by looking at its equation? Well, don't these things give us the center? So I can find the center. And I can find the radius. And let's find the center. Center, it's going to be, we go to the right 4 and then down 1. And the radius, this is r squared. So wouldn't the radius have to be 4? All right. So here we go. The next thing they want us to do is sketch this. So at some point, I know I don't have any graph paper on this thing, you guys, and I might. I'm not sure if I'm going to change it. Let's actually see what we got here. Yeah, I can probably put a piece of graph right here, so I will. I apologize, I don't have it on this one. But the center's at 4, -1, so we're going to put it at 4, -1. And then we said the radius was 4. So from here, I'm going to go up 4. 1, 2, 3, 4. Right 4. 1, 2, 3, 4. Down 4. 1, 2, 3, 4. And left 4. 1, 2, 3, 4. And I'm going to draw this guy. And it's horrible, but that's how it would be. There it is. Okay, that would be my circle. That's all that I need. Center and radius. All right. But I will put a graph on there, kind of like what I did in the first part. All right, so I sketched it. I'm done. Okay. Question 138. Look at the work from question 133. We actually didn't do 133. It's the non-function y equals, or x equals y squared. That's this guy right here, okay, guys? It had its graph that's called a sleeping parabola. How can you transform the equation of y equals plus or minus the square root of x to move the graph horizontally and vertically? How can you transform the equation to stretch or compress? Well, here's the deal, or flip. If we look at this, guys, we've actually talked about this. We would have y equals, we'd have an a value out in front because that's my stretch, compression, or reflection, times the square root of x minus h, and then we'd add a k out there, right? Because that's my square root function, and that's what I would use for my graphing form, okay? All right, write the general form by transforming the sleeping graph. by using A, H, and K. Oh, right, so I actually did. Yeah, so I guess I just wrote it. So if I'm gonna transform it horizontally, I'm putting something in here. If I'm gonna transform it vertically, I'm gonna put something there. Well, how could you transform the graph, stretch, or compress? I'd put something out there. And actually, it wouldn't be like this. You'd have the A here, and it'd be plus or minus, because the positive would give you the positive one. It'd do something like this, and the negative would flip it down. Kind of almost like a half eye, because I put it like that. That's how I made my eyes. All right, here we go, B. So write the general form. So I do have the general form. My general form is y equals plus or minus A times the quantity x minus h plus k. Write the equation for a sleeping parabola in standard form by isolating the x on one side of the equation. All right, so here we go. This is kind of interesting and weird, but here we go. Y equals plus or minus A times the quantity x minus h plus k. All right, I want the x by itself. We're gonna subtract k. Y minus k equals plus or minus A times the quantity x minus h. All right, next thing we're gonna do, let's see here. So there's a couple things I could do. I don't wanna square it just yet, you guys, because I wanna get that by itself. So I'm gonna divide it by positive or negative A. All right, so, and what I'm gonna do is I'm gonna kind of change that a little bit. So rather than dividing, couldn't I just make this like 1 over plus or minus A? All right, and then that would be times y minus k. I know where I'm going with this. That's gonna equal the square root of x minus h. Okay, we good? So these guys would divide out. So dividing is like the same thing as multiplying by the reciprocal, which is what that is. All right, now I'm ready to get rid of this square root because I want the x by itself. So I'm gonna square this side, and I'm gonna square this whole thing. Okay, so here's what happens here, you guys, when you square it. If I square this guy, I'm gonna have 1 over A, and I'm gonna end up squaring that, and it's positive or negative. If I square anything, you guys, it's going to be positive, okay? So when I square this, it's gonna be 1 over A squared times the quantity y minus k squared, okay? That's gonna equal x minus h. All right, then I'm gonna add h to both sides, okay? So next thing I'm gonna do, I'm gonna take this guy, I'm gonna have 1 over A squared times the quantity y minus k squared. Pencils are not working for me today. Plus k. And this should be plus h, my bad. Okay, and that equals your x. So here's the deal, you guys. These are non-functions, and when I square things, because I don't want to, this guy right here, we're actually not gonna square. That's gonna actually it's gonna actually be a weird kind of compression, and it's gonna be a compression that ends up making it go horizontally or vertically. It's kind of interesting that way. And that would be your transform graph. All right, so there you go. Big highlights for this thing. Writing the equation for a sleeping parabola, just kind of did that. Although this, rather than having 1 over A squared, you're gonna see this as B because it's a different kind of transformation. B times the quantity y minus k squared plus h, and that's gonna equal x, okay? B's gonna come more into play whenever we talk about trig functions, okay? And we actually did not have a B in this guy. And the reason we did not have a B in this guy, you guys, is because our parabola was just going, we had a regular shift. If you look at it from here, we went up. We're not thinking about going up 1, we're going to the right 1, and then we're going to the right 4, and then we're going to the right 9. So we're actually stretching it out this way. It'll be differently that way. And that stretch is what we call a B value, which is a horizontal stretch, which again, we talk about hugely in sine and cosine graphs. You guys won't have to worry too much about those until the end, but I know that that looks kind of different, but they just give it a B value. All right, so there you go. At this point, you're ready to get your homework. I will see you later. Bye.